So sine law, cosine law, those are the two tools you're going to need in this course for trigonometry. So far we were able to solve for any oblique triangle using the sine law. But what happens if you have a triangle without a pair? Okay. Well, I think you're already guessing, well, it's going to be cosine law, right? You guessed right. We need to use the cosine law in those situations. Okay, and so we've got two cases in particular. So some students like to just memorize these two cases, then they know it's cosine law, or I just tell students if you don't have a pair, it is going to be cosine law. So this is your first case. The first case is called SAS. So you have any two sides, so it could be this side length here, and this side length here, and you will know the angle in between. Right? That's SAS. And if you want something quirky to remember it, angle is sandwiched. Yeah. So the angle is sandwiched between the two sides, then you know it's cosine law, right? The other one is the side, side, side. This one I would argue is the easiest to identify. So, right, all three sides are known to us. Most definitely cosine law. First of all, because I just told you. Second of all, there's no pair to be had, right? There's not even a single angle there. So sine law is just goes down the drain, okay? And then this one, sometimes students mistake this one for sine law, but I would argue like there is no pair, right? There's nothing opposite this angle, so you're stuck. You have to use cosine law there. You can't just keep using sine law. And I want to say this, cosine law, just like sine law, works on right triangles as well. Oh, there's a joke alert. I can't pass this up, right? Why couldn't trigonometry get a loan? Because no one would cosine. Well, especially if you're younger, the banks usually won't give you a loan just like that. Your parents, guardians, or somebody's gonna have to co-sign it, right? Saying, if my kid doesn't pay this loan, you're on the hook for it as the parent, or whoever co-signed. Your uncle might co-sign for you, so that's why the trigonometry didn't get a loan, because nobody would co-sign. So there you go. Just forget about it. If it hurts your brain. Morning. Page 15. All right. Side angle side. How does that work? How does the formula work? Before you panic, okay? Both formulas are technically the same, but we massage them to look differently so that they're easier to solve for. Okay, guys? So I'm not technically giving you two different formulas. They're originally the same, but they've been rewritten to fit the case. Okay? So side angle side is when you have, I'm just going to grab these two sides. Let's say we know side C and side B, and we know this angle in between. Okay, and I'm going to use highlighters here, so be ready for that. The only option you have here to start off with is to solve for this side that's across the angle. That's a bit of a pattern here. Okay, so this is how we would start. A squared would be found by going b squared plus c squared. So these other two sides, and you're like, it's Pythagorean theorem, right? No, not yet. Not so fast. 2 times b times c. So the two sides you squared and added show up again here, but this is all multiplying. Okay, watch this. Times cosine of the only angle that you know, which is A. So all these letters on the right-hand side are known to you. You will know a number to plug in there. And this is where the highlighter comes in. Okay. So if you want to know this side, which is this one, okay, you're going to grab And the order doesn't matter for these ones, right? So you have C there. And you've got B here. So this side shows up here. I don't know. If you don't like highlighting, that's okay. But I thought it's probably a good idea to have these like that. And just so you know, how do you know you're solving for the right side? Okay, well, you have that angle A here. This kind of gives it away that you're solving for side A. I want you to look at the patterns, not always the letters. Because if you just focus on the letters, what if you get a triangle with different letters, X, Y, Z, or so forth, right? So, oh, I have another color yet showing up here. The angle, this one, this angle right here. If you want that, that's this angle right there. So that number is going to come in here. Okay? Here's another variation of it. Another variation. So let's say you got to use your imagination. I won't rewrite this, okay? But let's say you knew these two sides and the angle in between. That would mean that you're able to solve for this side, correct? So this is the pattern then. You would start your equation by going b squared, right? So this side is the one that you're trying to solve, which means that now these two sides are what's going to show up here again and again. So it would be a squared plus c squared minus 2 times a. Usually that's the pattern I follow. 2 times a times c. Okay. Followed by cosine of angle b, right? Because it's side b that you're solving for. So that's the variation for a triangle where you know these two sides and the angle between. You want to find that side. This is what you would follow. Just look at the pattern. Lastly, if you knew these two sides and the angle in between, that means that you would be able to solve for that side right there. So using this pattern here, that would mean that I would have c squared here. And then you're left with a and b, correct? So you'd go a squared plus b squared minus 2 times a times b times cosine of c. I would argue do not have all of these on your study sheet. I would just say this one right here. Okay, so later on I'll box in this entire region here so you have both formulas on your study sheet. Okay, so this is it. That's when you have an SAS, the sandwich, right, angle sandwich between the sides. What if you have all three sides? Okay, what if you have all three sides? The trick with all three sides, folks, is that you can choose which angle you want to solve for. And that is the kicker. You got to be careful here. You could solve for any of the three if you wanted to. But let's say you wanted to solve for angle A here. This is how you would start it. You would actually start it with cosine of angle A is equal to, and this gets a little ugly, but you'll see I'll work with it. It's just fine. Make a big line like this, a long line, okay? And then have a plus and a minus like this. Every single time you're gonna add two things, and then at last you'll subtract. Can I undo something here? Control Z, go. I wish I could. This one I'm gonna use a red pen for this A here because I want to highlight something here. Because remember, you can solve for any of the three angles you would like. It's your choice. But sometimes I will ask you to solve for this one, like a particular one. Guess which side would have to be at the very end here? If it's angle A that you're looking to solve for, then you would have to have side A at the end here. squared. That's the most important number that's going to show up here. So once you've used up A, which indicates you're trying to solve for angle A, then you grab the other two sides. So it's B squared and C squared that go on top. At the bottom you have 2 times B times C. And if you're wondering where in the world did this come from, it actually came from this equation. We just rewrote it and did some arithmetic with it to make it look like this. Okay, so that's the only reason why. And you should see the right, the 2BC was used to be right here, okay, and so forth. So that's it. So if you wanted to solve, let's say you wanted to solve for angle B here, this one, then you'd have to start your formula with cosine of B. You make a long line because you're going to have a fraction here. Every time you're going to have a fraction. You go plus, minus. Which side is going to go up at the end here? Since you're solving for angle B, you're going to grab the side length that's across that angle and subtract it here. Which means that if you've already used up B, it doesn't show up anymore. You're left with A and C. So this is A squared plus C squared. And the denominator, the bottom part, is 2 times A times C, like that. So, right, this A shows up here. Common mistakes is students forget to square. All the top numbers have a square. So if you copied this just now, make sure that that's indeed what you have. The bottom is not squared. It's just 2 times B times C. I use brackets because it's kind of saying plug in values there. Okay. Last one, if you wanted to solve for angle C, guess what? You would go cosine of angle C, long line. You know it's plus or minus. The reason I'm emphasizing it, doing it this way, is because I want you to make sure that the side across the angle you're trying to find shows up first, because if you get this wrong, everything will be wrong, okay? So then if you've already used up side C, that means that A and B are still available. So this is A squared plus B squared. And then denominator is 2 times A times B. Okay. So for your study sheet, I would say study sheet. If you have your study sheet on you right now, I would say cosine law, page 15, right? Just to tell yourself on your study sheet, I need to somehow get that page 15 on here. The note, I'm going to give you a note for both of these cases. The note here would be you must use square root, okay, for final answer. That is the most common mistake, that students forget to square root their final answer, and then it's this huge number that doesn't make sense. Okay, so this is note for this side. Note for this side. We used to use sine inverse for angles, right? What are you going to use here? Cosine inverse to figure out the angle here. So you must use cosine inverse for final answer. And I will highlight that as well, like the cloud, just so that you know that should probably go with your formulas as you're entering them onto your study sheet. I would strongly recommend that. I would say have these on your study sheet, but let's say you draw a blank. It's an AC or exam and you forgot to put it on there. Both laws are actually represented on your formula sheet. Okay? They just don't have a diagram. And look, they're using a little bit of a weird bracket here. So but if you don't have it, at least it's going to get you further than not having anything. Okay? So let's put this to the test. Let's see if we can actually use them. Because if you know how to use them, you're already in pretty good shape. Let's go to page 16 here. Cosine law to solve for side lengths. It's an SAS, okay? The question says, calculate the length of side A. So this is our question mark here. Okay, page 16. So we know this side, we know that side, and we know this angle. Right? SAS cosine law. Did you know that the province gives you 1 mark automatically if you pick the right law? Just for picking cosine law, you would already get 1. Okay? It's 1 out of 3 or 1 out of 4, depending on how much work it is. So if you got trig down, you're going to gain a lot of doable marks, I should say. Okay, so how does this work? If I want to find out what A is, okay, in this particular case, I would have to square and add B and C. I'm going to use my formula, actually going to write it out, minus 2 times B times C times cosine of angle A in this case. You don't have to do this, by the way. Down the road, you just substitute numbers in. So A squared is B squared. So B is 7.9. So I'll go 7.9 squared plus C squared. So it's 5.2 squared minus 2 times B times C times cosine of 43. And this is where you want to have a good calculator. Okay? For trig in particular, if you have a good calculator like a 2-liner, this is very, very simple to do. What I do is automatically I will say to get A, okay, let's do it this way, especially for the beginning. I'm going to square root this side. I'm going to square root whatever I get on the other side. I'm actually going to figure out what this is and put that number under the root. So let's practice this. You should practice this with your calculator. So I'm going to go 7.9 x2. I have an x2 button. If you don't, figure out a way to raise it to the power of 2. Plus 5.2 x2 minus 2 times 7.9 times 5.2 times cosine of 43. So I typed everything in one shot. And you get 23.361, and it keeps going, right? We're going to use 29, sorry. Did I say 23? 29. All of those decimals. Do not round just yet if you want full marks. Because there's something called rounding too soon or rounding early. Okay? So A is square root of that number you just got, which is 5.42. And that's in centimeters. That's your final answer. do you have a pair now? Yeah, now you have a pair. If you wanted to switch over to sine law now to solve the rest, you would be free to do so. Is this a side, side, side now as well? Side, side, side. You know all three sides. So you could use cosine law to find out the remaining angles as well. So as soon as you find stuff, you can do more with it, okay? You get to practice in a bit. Or should I get you to practice right away? I'll get you to practice this once before I move on, okay? So let's go to 17 and use this to model the work. I think you just need to get in there once and try. So page 17, let's just try A. If you have enough time to do B as well, go for it. But just do, on page 17, do that first question here. Watch this. This is your side. This is your other side, and that's the angle. This is side angle side. So you have to solve for side R. Can I just recommend something today? You're listening, right? Write out your formula with letters only first, and then plug in the numbers and solve, okay? Just so you get a hang of the formula and the pattern. I'll let you to it. So we're going to do the SSS in a bit. Let's just go through this one more time. So in this case, you know it's not sine law, right? I hope you all agree with me that there's no pair. You can subtract from 180 because you only have one angle. So you're stuck, right? So SAS, it's cosine law. Using these letters that are here, you'd have to go r squared is equal to, what are these two letters? If this is capital Q, this is lowercase q, capital P, lowercase p. So it's Q and P are the other two sides. Cosine of R. Okay, so if you use these letters, and I don't care if you used ABC to be honest, because I just want you to know what the pattern is. Okay? Letters mean a lot, right? Like you should see, oh, lowercase r, capital R, so these are opposite each other. And these must be the other two sides, right? Something like that. That's what I want you to think of. So r squared is going to be found by going 4.3 squared. I may not do this in the order that I said, but the order doesn't matter of the two sides that you're plugging in here. So this is cosine of 91. Now you need to I need to cover this. This is very important. It relates to this box right here. And I'm going to bring it up enough times that you're going to hopefully remember. But cosine of an obtuse angle is always going to be a negative value. Okay, you need to know that. It doesn't affect you if you're using one of my calculators or a calculator that shows you everything. This doesn't affect you at all. Like you'll never have to worry about this. But if you do this in steps, you will have to watch out for it, because cosine of 91, just type in cosine of 91 separately. I don't know if you realize, some of you may have realized that this is actually negative 0.0174, and it keeps going, okay? And what this negative does, pay close attention to this part, please. This negative ripples through all of this, right? And so it makes this whole expression negative. Anybody remember when two negatives meet, what does it turn into? Actually positive. So if you do this in steps, you have to watch out for it. Like this negative and that negative is positive, so it's actually 4.3 squared plus 6.5 squared plus it turns into a positive. It doesn't cancel, but it turns into a positive. Yeah. So again, if you have one of these that has two lines, you will never have to worry about this. Like it's just not going to be an issue for you. But if you do this in steps, you need to watch out for, right, these two negatives turn into positive, right? So I'm going to have this here for some of you might need this. Okay? turns positive, okay? Oops, can't see that, now you can. So again, it doesn't affect you if you use my calculators. So I wouldn't even, you don't even have to write this down. So R is going to be found by taking the square root of all of this. So I entered all in one shot, 4.3 squared plus 6.5 squared minus 2 times 4.3 times 6.5 times cosine of 91. I get 61, 71, keeps going. Don't round, okay? If you want full marks, you do not want to round until the very end. So it's 7.86 rounded, okay? That's your final answer. We are in kilometers. Okay, there we go. You don't have to worry about this if you use my calculators or if you have a two-liner. But some of you have a calculator where you have to do this in steps, so then you have to watch out, okay? Let me just give you, can I give you the answer to B? I'll leave that up to you. It's 8.55 centimeters. So you can write that down in brackets so you know what the answer is. I will leave 18 for now, page 18. We're going to go to side, side, side. Also 19, I'm skipping it for now, but we're coming back to it. We're not just going to have triangles, we are going to have word problems around it, okay? Page 20, please. Cosine law to solve for angle measures. And that's when you have a side, side, side scenario. A, right? A, solve for angle A. What is the three-letter notation for this angle? Remember the three-letter notation for any angle? If this is the one you want, A is going to be in the middle, okay? And you're going to have two letters on either side of it. And the choice is yours, what you want to do. You want to go CAB. Oops. Or you can have, right, A is going to be in the middle. Or you can start from this side. You can go BAC. That's also an option. What am I doing? BAC there. So angle, angle. So both of these are still talking about angle A. Okay. Just a reminder. Okay, let's solve for angle A. That's what we're here for. We want this angle right here. Question. You know it's side, side, side. You know it's going to be cosine law, guaranteed. You don't have a pair, you don't have a single angle, so you must use cosine law. You're going to go to your study sheet and you're going to be like, okay, this angle is what I want. That means that I'm going to go line, plus, and minus. Which side is going to go over here? The one that's opposite to it, so 18. So this would be 18 squared. Then you focus in on the other two sides. You go 30 squared plus 22 squared. No decimals right now, just to make it a little easier for us, but there will be decimals down the road. In the denominator, we're told to go 2 times this first side times the second side. And we can solve this in 3 lines if you do it right. What I do here is I'll do this separately. Okay, I'll do the top, put the number down, then do the bottom part, put the number down. So let's do that together. 30x2 plus 22x2 minus 18 squared. That gives me 1,060. 2 times 30 times 22, that's 1320. No decimals, so it makes it a lot easier. So now let's divide these two. 1,060 divided by 1320. You get 0.803 0, and it keeps going. Do not clear that from your screen. Leave it on your screen. So this is actually, there's nothing wrong with this many equal signs. We're kind of reducing this ugly fraction and turning it into a decimal. So here it goes. To find angle A, or whatever letter you're trying to find, whatever angle, you're gonna take cosine inverse of that number that you just reduced. So you grab your calculator, and I have to press shift, and then cos to get the inverse, and then I can hit equals. You might have to press the answer button. But it's 3658. Yeah, 3658. There you go. You solve for angle A. You could have solved for any angle, by the way, at the beginning. So you solve for angle A. And one more. This one is going to be interesting. You're going to have a negative show up. Determine the measure of the largest angle. What would the three-letter notation for this angle be? Which one is the largest angle, you think? It's going to be across the longest side. Okay? That's how you know. That's how you know. Okay? Unless you know all angle measures, that would be even easier, but if you don't. So which is the longest side? It's AB, right? Let me go up to that triangle again. This is in terms of the numbers, don't worry about the diagram. Let's look at the number. This is the longest side, largest angle. So angle C. So therefore, angle C is the largest angle. So that's the one we're going to try to find. So here we go. Don't just put C down. You got to go cosine of angle C. Let me bring this up for you here. I wish I had the triangle in front of me right now, but it is what it is. Which number will go across here? 30, right? Yeah. 30 squared. And the other two, they go in front. So 22 squared plus 18 squared. Doesn't matter which order you do them in. Okay? In the denominator, it calls for 2 times this first side times the second side. And let's clean this up. Let's do the top. I would invite you to do that because you're going to have to deal with a bit of a surprise there. If you hit equals, you get a negative. But do not get rid of it. It's okay. It's supposed to happen. The denominator is 2 times 22 times 18. That's 792. Before we continue, this negative indicates to us that you have an obtuse angle that you're going to find. What's an obtuse angle? It's bigger than 90. Guaranteed. Okay? So this is worth highlighting. Okay? So what that means is that our decimal that we're about to get is going to have a negative in front of it for sure. Okay? So you're going to go 92 divided by 792. That's 0.116. And that keeps going. And if you're not sure, my calculator, I can go minus 92 divided by 792. I can actually do that, but some calculators might not let you do that. You have a plus minus, like a plus slash minus button. That might be how you get the negative in there. But you have to have a way to get the negative. Okay? Leave this on your calculator. And then go angle C is going to be found by going cosine inverse of negative 0.116. And that keeps going. And so I go shift, cosine, and then I hit equals, and you get 96.67 degrees. Don't forget the degree if you're, and I'll make a note, right? This, right, this one tells us indicates an obtuse angle, okay, greater than 90 degrees. What's the three-letter notation? I never did that. Angle C is also, you can do the, you need to make sure C is in the middle. Go up to the triangle, so it's BCA, right? Angle BCA, or to be honest, you just read this backwards, ACB. They all mean the same thing. If you have troubles with the negative, I'm going to give you some time to work with this. You talk to me. It's like, I can't do the negative. How do I do it with my calculator? I'll be more than happy to help you with that. Last but not least, the remaining angle. That would be angle B. I'm just going to go 180 minus 96.67 minus 36.58. Mr. Durson, could I do cosine law again? You do that if that's what you want to do, go for it. But I would say it's too much work, in my opinion. And I don't like to work if I don't have to. 36.75. So you basically solve the triangle now, right? All three angles are known. Okay. Mr. Dirksen, right at the beginning, when I found that first angle, did I have a pair? Yes. Could you have used sine law to move forward? Yes. I just chose not to do it because we're trying to focus on practicing this, right? Cosine law, involving the side, side, side. Okay. I want you to practice this before we move on. So, I'm going to ask you to try page 21. And keep going, okay? I might take a little bit more time to go around. So page 21 and 22 for now, and then I'll give you some more to try, but can I ask you to pay attention before you start? What does it say here? Solve for the largest angle first if you have a choice. Get that one done first. Which one would be the largest angle in this one? Which letter? It'd be angle P, right? Because it's across the longest side. So solve for angle P to get you started, and then do everything else. Okay? Practice that. I'll come by. If you're done this, go to page 22. Okay. I like what I see. Awesome work. I'm just going to say this, okay? Blanket statement. Page 17 all the way to 22. We did some work already on 17, like I did a question with you. But anything, there's some word problems there, there's some interesting stuff there. I'm just going to post all of that. Do as much as possible, okay? So that you know both cases, you know how to work it, you know how to use your calculator.